In this video, we're going to look at a few inequality problems from section 1.4 of our intermediate algebra course. I'm jumping ahead. The first half of the homework is introducing the concept of graphing these solution sets and of writing them in interval notation. And so it spends several problems just kind of individually addressing those topics. I'm just going to address all of it together with these inequality problems. So let's go ahead and take a look at this first one. So we have 9x plus 3 is less than 84. The first thing we want to do with these inequalities is solve them for x. And you will solve them for x exactly the same way as you solve an equation. So you're going to isolate x, try to get x by itself on one side. First step, just like we would do for an equation, is to subtract 3 from both sides. So we're going to get 9x is less than 81. And then we'll divide by 9 on both sides. So that's pretty straightforward. So we get x is less than 9. So that's solving the inequality for x. That's the first step. Get x by itself on one side, just like you're solving an equation. The other things you might be asked to do in this section are to graph these solution sets as on the real number line and to write them as intervals. So I'm sorry, I got those two confused when I was talking just a moment ago. So to graph this on the real number line, oh gosh, that is a terrible line. Let me try that again. So let's see if we can go straight across. It's a little bit better. All right, so real number line is this concept of a horizontal line on which we will find all the numbers. So every number that you can think of is somewhere on this real number line, unless it's an imaginary number. So 0, for example, would be on the real number line, and I kind of like to think of that as the middle. And 1 is on this number line. It'll be to the right of 0 because it's bigger than 0. 2 would be on this number line. 3 would be on the number line. 1/2 is on here. We don't normally mark that number, but it's there. Right? It's between 0 and 1. Pi would be on the real number line. Right? It's 3.14. Right? It's going to be a little bit after 3. So just every number is going to be somewhere on the real number line, and they are placed in order. To the left of 0, we'll have the negative number. So I have like -1, -2. Right. So we're being asked to graph this solution set, x less than 9. A number will satisfy this inequality as long as it makes it true, and it'll be true as long as the number we pick is less than 9. So if we pick 8, for example, and plug it in here, 8 is less than 9, so 8 would be a solution. 7 is less than 9, so 7 would be a solution. 0 is less than 9, so 0 is a solution. And we could keep going. There's actually an infinite number of values that would make this true. Any number less than 9 is going to make this a true statement. And so we can't list them all. There's too many to list, which is why we're resorting to drawing a picture. We're going to graph it. Now this one, usually I don't label 1, 2, and 3, but since I did, I'll go ahead and keep that. And we're going to have to go a little bit of a ways out until we finally get to 9. But 9 is sort of the pivotal number here. Any number bigger than 9 would make this false, and so therefore would not be a solution, like 10. 10 is not less than 9, so 10 is not a solution. So if you think about the numbers we just listed a moment ago, we talked about 8, that's a solution. We talked about 7 being a solution. We talked about 0 being a solution. All the numbers that are less than 9 will exist to the left of 9. And so every number to the left of 9 would make this inequality true, so we want to shade in all of those numbers. So we're going to shade in all the numbers to the left of 9. All right, so here's 9. We're going to shade in to the left. So all of these numbers here. So everything that I've covered in red would be a solution to this inequality. Now the number 9 itself actually is not a solution. If I plug 9 in for x, I'll get 9 is less than 9, which is not true. So when I reach 9, that's the first number that actually doesn't work. But I have to go that far because, for example, 8.9 works, right? 8.9 is less than 9. 8.99 is less than 9. So I have to shade in all the way up to the number 9 so I can include numbers like 8.999999. But the number 9 itself needs to be left out. So the way we denote that is using a parentheses to show that we're including, where we are, how do I want to say this? The solution set is all the numbers up to, but not including the endpoint, which in this case is 9. So that's what the graph would look like. less than, you want to shade to the left. If you're looking for numbers that are bigger or greater than, you would want to shade to the right of the number that's given. You use parentheses if there is no equals to show that we're not including the endpoint. You use a bracket to, when there is an equals to show that you are including the endpoint. So if this had an equals to on it, we would make this into a bracket symbol to show 9 is being included. We'll hopefully see an example of that here in a minute. Okay, so that's how you would graph the solution set. On Math Excel, this is going to be multiple choice. If you're asked to write this as an interval, interval notation works like this. You give two numbers, and what is indicated by these two numbers is you want the set of all numbers in between the two that are given. So A comma B would indicate all the numbers between A and B. So that's what we mean by interval notation. Now, you do have to be careful when you set this up. There are some rules about the way this has to be constructed. The number on the left has to be the smallest number in your set of numbers. So you have to go from smallest to largest. B would be the largest number in your set of numbers. And everything in between is also included. So for example, if I say 1 comma 5, I'm talking about all the numbers between 1 and 5. So that would include 2, that would include 3, that would include 4, that would include pi, that would include 1.5, it would include 4.5, 4.9, all the numbers between 1 and 5, decimals, fractions, whatever. So that's how interval notation works. You could not write it like this. This is not acceptable. This is not an acceptable way of formatting it. It needs to be smallest number first, largest number second. So don't write it like this. It needs to go from smallest to largest. So if we go back to our solution set and look at what we've shaded in, we want to go from the smallest possible number to the largest possible number. So let's start with the largest one first, because that one's just easier to tell, right? The largest number we have shaded in is the number 9, but not including 9, but all the way up to the number 9. And we do the same thing in the interval notation that we did in the graph. To show we're not including the 9, we'll use parentheses. Right, so it goes up to, but not including 9. Just like down here, this is all the numbers between 1 and 5, but not including 1 and not including 5. Those are not actually being included here. All right. So let me write that again. Okay, so this is 9, and let's put parentheses here. Okay. Now on the left-hand side, and that's going to be the largest number, so that goes on the right-hand side. The smallest number, well, this keeps going forever to the left. So the correct response here is that there is not a smallest number. It just keeps going. So if you thought -2 was the smallest number, well, that's not true because -3 is also on here. And it just keeps going, so on and so forth. And so to indicate that there is no smallest number, we use the concept of infinity. And because this infinity is going in the negative direction, we label it as negative infinity. So this graph just keeps going forever to the left. It's going to go all the way to negative infinity. That will be our smallest number in our interval. So put negative infinity here. For infinity, you always put a parentheses on it. You never put a bracket, because you can never contain infinity. Right, so you put smallest number first. In this case, there isn't one, so we use negative infinity. Largest number second. In this case, it's 9. And that's how you write the solution in interval notation. All right, let's take a look at another example. All right, so we have 2x minus 1 is less than 6. Sorry, I said x. It's y. 2y minus 1 is less than 6y minus 2. I think I said x. I don't know. It's kind of late, so I think I'm kind of losing my mind a little bit. All right, so we're going to solve this inequality just like we'd solve an equation. I'm going to start by getting my y's to one side of the inequality. So I'll subtract the 6y from the right-hand side. Do the same thing to the left-hand side to balance that out. So we get 2y minus 6y, which is negative 4y. We have the minus 1 less than, and then the minus sign here becomes a negative sign, so negative 2. All right. And then to solve for y, we'll add 1 to both sides, just like we would if we were solving an equation. Get negative 4y is less than negative 1. And then we divide by negative 4 on both sides. And what we're going to get is we're going to get y on the left-hand side, -1 divided by -4, unfortunately, it's going to stay a fraction, but the negative signs do cancel each other out. And so we'll get +1/4. And here, for the inequality symbol, we actually have to do something special because we divided by a negative on both sides, even though I kind of covered it up there. We have to flip the symbol the other way, right? So it was a less than, but because I divided by a negative, it gets flipped around and becomes a greater than. The reason that has to happen is not because it's some fancy thing going on with algebra. That's just the way numbers work. So if we set this up, we have 1 and we have 2 here. 1 is less than 2. Right? So that's a true statement. There's no algebra here. I just have numbers, and I've made a true statement. 1 is less than 2. If I decide to divide by a -1 on both sides of this inequality, just for fun, the left-hand side becomes -1, the right-hand side becomes -2, and if I want this to still be true, I have to put a greater than symbol here. -1 is greater than -2. So it's just a fact of numbers. When you divide by a negative on both sides, it changes which side's bigger and which side is smaller. And so we have to flip the symbol around to reflect that. All right, so this is solving it for y. Now we want to graph this on a real number line. Oh gosh, that was terrible. Okay, sorry. It's kind of hard to draw a straight line on this tablet here. So there we go. That was a little bit better. Okay, so again, I always like to put 0. I put that in the middle. I'm not going to put 1, 2, 3. I'm just going to jump to the number here. It's 1/4. Because it's positive, I do know it'll be to the right of 0. So let's say it's right there. And I'm looking this time for numbers that are greater than 1/4. Right? I want numbers y that are bigger than 1/4. Where do I find numbers bigger than 1/4? To the right of 1/4. Right? So any number over here to the right of 1/4 is bigger than 1/4, and so therefore will satisfy this inequality. Again, there's no equals to here, so I'm going to use parentheses on the 1/4. So that's what my graph looks like. As an interval, this time, the smallest number is 1/4, right? So the smallest number is the number furthest to the left in the shaded region, and the furthest left I shaded was 1/4, not including 1/4, but all the way up to 1/4. The largest number, there isn't one because this keeps going forever to the right, so we use the concept of infinity to describe that. There is no largest number because it goes on forever, and so we will use infinity in our interval. And again, always parentheses on infinity. So that's what the interval will look like. All right. So this one also doesn't have an equals to, so I'm going to change this. I'm going to call an audible here. I'm going to put an equals to on that inequality so we can at least have one example of that. So this one looks a little bit scary, but it's not too bad. You just have to solve it just like you solve an equation. The first thing we want to do is get rid of the parentheses. So we'll distribute the 2. We're going to get 6 minus 14x. The plus 3x just gets copied down. We don't distribute the 2 to the 3x because it's not in the parentheses. This will still be less than. Do the same thing here. We'll distribute the 3 into the parentheses, so we get 15 plus 6x. All right. And so before I start moving things from one side of the equation to the other, I'm always advocating simplifying first. So combine like terms. So I'll copy the 6 down. Negative 14x plus 3x will be negative 11x. Less than 15 plus 6x. All right. Now I will move x to one side of the inequality. You might consider adding 11x over to here to keep the x positive, but there's also a drawback in having x on the right-hand side. It's more difficult to determine the solution set. Inequalities are always easier to interpret if you have x on the left-hand side of the inequality. So even though it's going to come out negative, I'm going to go with it this way. So I can keep x on the left-hand side so I can understand my answer better. All right. And while I'm at it, let's save a little bit of time. I'll go ahead and subtract this 6, get rid of it from the left-hand side, put it over here. So that 6 is gone. Negative 11x minus 6x will be negative 17x. This is still less than. It doesn't flip around even though we're subtracting. It's only if you divide by negative or if you multiply by negative. All right, so this will still be a less than. And this will be 15 minus 6, which will be 9. Okay, I was going to say, is it 9 or 11? It's 9. So let me try that again. All right, so we get 9. And then these 6x's cancel out. All right, And then we'll divide by negative 17 on both sides. And we're going to get x is greater than negative 9 over 17. Right? So now the symbol is going to flip because we're dividing by negative on both sides. Again, this will stay as a fraction. It's a negative fraction because we have a positive divided by a negative, so the fraction will be negative. So this is solve for x. To write, or not to write the answer as an interval, but to graph it, well, it's going to be very similar to the last example. So the graphing part of this kind of gets redundant after a while because it will kind of just, once you solve it for x, it's kind of the same situation every time. Oh, I'm sorry, I forgot. We're supposed to have equals to on all these. Let's go back and do that. All right, so this time I decided let's have this be equals to, so negative 9 over 17 would be to the left of 0, negative 9 over 17. We're looking for numbers that are bigger than or greater than that, which will be to the right of negative 9 over 17, right? Numbers will be bigger to the right, so we want all the numbers to the right of this. All these numbers here are bigger than negative 9 over 17. This time, since we're including negative 9 over 17 with the equals to, we're going to use a bracket in the graph. All right. And the interval, again, goes from smallest to largest. The smallest number, the number furthest to the left, is negative 9 over 17. The number furthest to the right is infinity because it goes forever to the right. This time we put brackets on the negative 9 over 17, just like we did in the graph, for the same reason. We want to include it in the solution set because of the equals to. But the infinity we never can include. We always put parentheses on infinity. All right. Okay, I think I have one more example. And I thought I would do this one because I thought when you saw this on the homework, the fractions might concern you. So what I would do with this is get rid of the fractions just like we would if this was an equation by multiplying the common denominator to both sides. So the common denominator in this case, we have 2 and we have 4. The common denominator is going to be 4. So I'm going to multiply 4 to both sides of the equation. Or sorry, it's not an equation. Multiply 4 to both sides of the inequality. Now what's going to happen when the 4 gets multiplied to the negative 5 halves? The way I like to, you could use a calculator. It's going to simplify nicely, and the calculator will give you the answer. But you could also do this in your head, and it's not too hard to do. Here's what you want to remember. You take the number you're multiplying by, which is 4, divide it by the denominator. So 4 divided by 2 is 2. And then multiply it by the numerator. 2 times 5 gives me 10. All right, so 4 divided by 2, which is 2, multiply by 5 gives me 10. The x gets copied down, the negative sign gets copied down. All right. When the 4 gets multiplied to this fraction, 4 divided by 4 is 1. 1 times 3 is going to be 3. All right. Again, the negative sign gets copied down, and the inequality symbol, because we multiply by positive 4, it doesn't get flipped around, so it stays greater than or equal to. Now that the fraction's out of the way, we can proceed to solve this for x a little more easily. And it doesn't take much, right? Just one step here. To get x by itself, we divide by negative 10 on both sides. The negative 10s cancel out, and we get x on the left-hand side. Here the negatives cancel each other out, and we get 3 over 10 on the right-hand side, positive 3 over 10. Since we divided by a negative on both sides, again, the symbol gets flipped around the other way. So make sure you're only doing that when you divide by a negative or multiply by a negative on both sides. All right, so there's our inequality. And again, I'll just, since I did it on all the other problems, I'll do it on this one too. Let's go ahead and graph. We have 0. We have 3 over 10, which is positive, so I put it to the right. We're looking for numbers smaller than 3 over 10. Numbers will be smaller to the left of that, so I'll shade to the left. Because of the equals to, I'll use a bracket on the endpoint. And then as an interval, we want to go from smallest, which in this case will be negative infinity. Let me try that infinity symbol again. Whoops, I hit the wrong button. Sorry. Let's try that again. Okay. Sorry, I tried to do undo, but it went back to a previous page. All right. So close to being done. Okay, so negative infinity. There we go. Comma 3 over 10. Brackets on the 3 over 10, always parentheses on infinity. All right, so good luck with completing the rest of the homework. If you have any questions, please feel free to contact me.